This meeting is being recorded.
For problem 29, we are asked to determine the structure of an alcohol. So we're told specifically that we're going to find an alcohol with this molecular formula. And we're given the signals that appear on a carbon-13 and a Mars spectra. And we can put together this compound based on these data. So let's first start with a hydrogen deficiency index calculation to find out the degrees of unsaturation. So we can do 1/2, 2 times 5 is 10, minus plus 2, right? And then minus 12. So we see that we have an HDI of 0. So that means that we're not looking for so any rings, so no rings, and no double bonds. So that will help us figure out our structure here. And we're told that in our broadband decoupled spectrum, we see 3 signals, one at 73.8, one at 29.1, and then one at 9.5. So with this information, we probably could see that we already have a carbon bonded to an oxygen, something like this here, which we would need for our alcohol. So that's probably the signal at 73.8. And then we see that since only one of these signals is in that range, that we do have an alcohol versus an ether or another compound that could have an oxygen in it. So we have a total of 3 signals, but we have 5 carbon atoms. So we know that we must have some type of symmetry. And both of these other 2 signals here, so the 29.1 and our 9.5 would indicate sp3 hybridized carbon atoms. So we can begin to propose a structure, right? So we have our OH, and then we have to incorporate that those degrees of symmetry here. So we have 1, 2, 3, 4, 5 carbon atoms, and this looks like it would produce 1, 2, 3 distinct signals. So far, this proposed structure can be correct, but let's verify with the other pieces of information that were given with our depth spectra. So we see here the depth 135 spectrum would confirm that we have the presence of a methyl group and a methylene group, right? So we have a positive signals here and here. So we have depth 135 positive would confirm a methyl group. The negative signal at 29.1 would confirm the methylene groups. And we see that we have only one signal for both the methyl and the methylene groups. So again, this structure that we proposed would align with all of these signals that we see between our broadband decoupled spectrum, our depth 90, and our depth 135. So let's draw our final structure. In conclusion, this would be our alcohol.